So we're moving on to geometric sequences, which is any sequence whose successive terms have a common ratio of r. This is also on your formula sheet, but these are the explicit and recursive formulas. So let's take a look at example 5. The first 4 terms of the sequence. So what this says is the first term is 4, and to find the nth term, you take the n minus 1. So once again, like before, if this is the term I'm on, this just stands for the previous term. And it looks like I'm taking the previous term times 6. So to find the second term, I would take the first term and multiply by 6, which is 24. To find the third term, I take the previous term and multiply by 6, which is 144. To find the fourth term, I take the previous term and multiply by 6, which is 864. The explicit formula, we need the first term and then the ratio. And the ratio you can always find r by taking any term and dividing by the previous term, the term before it. But in this case, I'm already given r because r I'm told in the recursive formula. So this explicit formula would be a sub n equals a sub 1, which is 4, times 6 to the n minus 1 power. Let's take a look at this geometric sequence. So 50, 25, 12.5, 6.25. I'm going to take any term. I'll just pick 12.5 and divide by its previous term. I know some of you can see that already, but it is 1/2 or 0.5. And the other thing that I need for my recursive formula is the first term, which is 50. So the recursive formula for this would be a sub 1 equals 50. A sub n equals 0.5 times a sub n minus 1. And this is for when n is greater than 1. And while we're at it, let's just practice one more time writing an explicit formula. For the explicit formula, we need a sub 1 and r again. So we would write a sub n equals a sub 1, which is 50, times r, which is 1/2 or 0.5, and we want to put that in a parentheses, to the n minus 1 power. So now we have examples of both arithmetic and geometric sequences and how you write their explicit and recursive formulas.